So no prizes for guessing what this one is. It's the Harrier CB in its box. With its instruction book, which doesn't have a circuit diagram. We already have this one on file. I nearly said foul. I was thinking about these ridiculous American cars in the illustration. There is the standard mic in there, and we'll do our test at the end with that. But we'll use our usual test mic for the service work. So, for those of you who don't know, it's a Cybernet 134 radio. And what's that say? S56 7 or is that 55677? I don't know. Looks like a Sheffield postcode gone wrong. So we'll plug into power, plug into the test equipment. They don't have public address, and high-low power is at the back. Now, where's that gone? I've got to keep an eye on the time. I've got a funeral to do. Scratchy Corner Church. So I'll do the initial checks. We're still on box 18, so there's 2 more radios to go in box 18 before we move on to the next box. So I won't open it up, we'll just go through it at this stage. Right, microphone. Oh, that says realistic on it. That is not very helpful. That's the one that says Cybernet. Somewhere around about the 9th. Really doesn't matter. We'll come to that. Here goes. Are we on channel 20? We are. And we have got £3 watts. On channel 40 we've got 3 watts. On channel 1 we've got 2.95. So it's best to have it within 0.1. So it's a service manual and it is within 0.1. We'll see if we can get that up a bit. So now we'll go to low power. So I've switched the test set to low power so that the full scale deflection is 3 watts. And we've got 50 milliwatts. Back to normal power. Oh, that was a flawed test. That was on channel 1. Still 50 milliwatts. Go back to normal power. And let's see what the power supply is drawing. It's 998 milliamps. So deviation, wallow. It's 2.2 to 2.6. That's actually alright, but we'll want to balance it probably differently. We'll come to that. And the frequency near enough, but we'll still pull it up. 2779103. Go to receive. I'm going to the signal generator is already set to 79125, so it's near enough for me not to have to match the transmit with the receive. So we'll leave it at that, and we'll go to the Cybernet meter, which has decided to be a bit on the low side today, and on the out of focus. Oh, it's focused itself. How clever. Right, we'll turn the volume up. So for 12 dB, we have got 0.83. They usually do work a little better than that, but that isn't a fail. For 10 dB, we've got 0.75. And if it'll do 20, not everything will, because it's all down to noise. It's doing 1.75. Squelch, just turn it to full, see when it comes in. I like them to be 100 microvolts, put that on the attenuator. So there's 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. Hey, no, nothing there. 300 microvolts it's coming out. Let's get an exact reading. It's 170 microvolts. So it's not too far out. And there's no hard and fast rule about that, but I like it to be 100. So we'll do the opposite, and we'll set the threshold, put the signal generator to standby. There we are, set to threshold. No, not too good. Hopefully we'll improve that. It's 1.8. It could start chopping around scratchy corner at that. So when we key up, what does the meter say? It says bob on 4 watts, but of course it isn't doing 4 watts. So it actually says 4 watts, but the radio's doing 3, which is actually how you're supposed to set them. So let's look at S9. It's a bit lazy. So S9 is there, and that is 210. Meter lamp's okay. There's only one switch, it's at the back and it works. Oh well, it's a nice set to start with then. Let's hope there's nothing scary inside it. There's also Fidelity 2000 in this box. There's also Fidelity 1000 in this customer's box. I can't see anything scary. Can't see any dodgy capacitors. Sometimes they've been overvolted and they're starting to pop the juice out. So we'll start by setting the VCO, which I've no reason to suspect has ever been fiddled with, but you just never know. So we'll do the right thing. I put this on channel 40, which is where we start, and with Mr. Chippy's stolen lead, we'll put that to our test prod negative, and with resistor 4 far end we have got a wrong voltage. So there you are. I'll still have to get my instructions out because I'm like that. Yeah, it's 4 volts. So we need to adjust the VCO on channel 40. I've gone and done the, no wonder I'm getting the wrong reading. It should be 4 volts on, it's not far out, but it's far enough out to adjust it. Oh, that's absolutely spot on. That doesn't often happen. Now we're going to transmit. It should also be 4 volts. That's within 0.1, so that's fine. Otherwise, we'd have to adjust the red trimmer. So now we just check it at the other end. Channel 1 on receive 1.9. That's fine. You want it to be something like, I could tell you exactly. 1.8 and 2.5, and on transmit well within. So didn't need adjusting, but I did just for the demonstration. So it was 4.2, wasn't it, instead of so it's it was 4.2, 4.0, and it's now 4.0, 4.0. Right, let's do the transmitter. So we'll remember to change to channel 20, and we'll put that on picture in picture in the right position. There we are. So I'm at full scale deflection on the 3 watt scale. I could change to the next scale up, but it's just easier to adjust these lower ones on that scale. I can get a more accurate picture of what's going on. The slightest movement and I'll see it. They were absolutely spot on, those 3. So now we'll change scales. So as I said before, we've got to peak this pretty quickly, because if this radio, supposing it does 5 watts at full, it needs to be back down pretty rapidly, because it can't sustain that. It's only supposed to be doing that to be on top of its job. So that's the first one. We're now at about 4.3. It's quite a good example, this one. Some of them you struggle to get 4 watts out of, and then you can't balance it that well. So I'm just going to check those again. It's like Teletubbies again. I've not had a telly for years. Perhaps they're not on anymore. I'm just going to recheck that one now we're there, because they are interactive. Right, and then quickly we're going to turn the yellow one L4 clockwise for 4.4 watts, which is there, and then we're going to turn the green one anti-clockwise. The manual says for 3.8 watts, but seeing as you're entitled to 4 watts, we'll set it to 4 watts. All they're trying to do is to get their radio through customs. Just while I'm at it, we'll just set the frequency as well. I'm going to go that way today. Oh, it's the right way. It can be either way, with it being a variable capacitor. Good. So although the PA is now warm, we do a quick check of power and see where we are. It'll tell me where, if I've got it anywhere near. So we'll go to channel. We are on channel 20. So bang on 4 watts. Channel 1, 4 watts. Channel 40, 4 watts. Well, I'll tell you what, you don't often see that. Now we'll do low power. And is this the switch playing up? Because it's not doing anything now. No, is it the preset playing up? Yep. It's not normally at one end like that, but it is on this set. No, I don't think the preset's broken, but it's certainly at one end. And the transmit current now is 1.143. So we've gained an extra watt for only 140 milliamps, which must mean I've improved the efficiency. Right, transmit meter is now banging across because we've increased the power. So now reset that to 4. Just like that. Now we'll do the deviation, which was spot on, but not how I wanted it to be. So I want that in the central position. Now we'll recheck it. Wallow. It's minutely too loud. It's so minute, but may as well adjust it. Let's try it there. Wallow. Too quiet now. Wallow. I'm just going to check it with the factory original mic, just in case that's higher gain. Wallow. It's exactly the same. And it's the same style of mic. So we'll carry on that adjustment with my mic. It just needs that little bit more. Wallow. It still needs a... Now wishing I'd never touched it. Wallow. Wallow. That's it. And that concludes the transmitter. Moving on to the receiver, we'll go for the oscilloscope first. All the cameras have moved again. I just find, I don't know what's happening in this building. Right, so we want S9 on the signal generator, which is there. Enough volume for a decent trace, and we'll just check that the detector's in the correct position. No, it's not. Okay, that's now in a better position. So that's now peak. So now we'll move over to the cyanide meter, the camera for which is also moved. And we want enough for about 4 dB. This set sounds weird. I'm going to do the IFs first. Tell you why. Because somebody's put a crystal filter in it. That's why it's different. And of course, you're never sure whether they've put the right one in, are you? And that core looks like it's broken. Right, let's see if we can bring it up a bit. Right. It is being dragged down a bit by this crystal filter. I won't take it out on condition that when we do scratchy corner it works properly. We've now got 0.7 microvolts. .6 microvolts. And 1.65. So I've seen more sensitive sets, but it may be interesting. You know, the customer may find it interesting to see how this affects the radio. It may well be better for bleeder if that's a problem. If it was my own set, I'd take that out, but it's not my own set. He'll no doubt comment on the video. Let's see how the squelch is. It's, for people who know about these things, and I don't, the filter's 10M15A. No idea what that means. Sounds like the bandwidth is 15, but I may be totally wrong. Might be the M that means something. But, you know, our whole thing is radios are put to factory original. I'll let crystal filters go as long as it's working. And it's working, but it's not as sensitive as I would expect. But if I put that back to a ceramic filter, it may not, you know, it may not be any better. So I don't want to be going backwards and forwards. But it certainly, it looks sensitive enough, and I have been able to improve it. So let's see if we can improve the squelch while we're improving things. So that's now got 100 microvolts on the attenuator. So I want to just adjust. That's a good phrase, isn't it? The squelch for, where's the squelch? Where's the squelch preset? Oh, it's that black thing down there. There we go. So that's now coming in at 100 microvolts. Let's see if it's improved the other end. So we'll turn the signal generator back to standby, turn the squelch down on the radio, set threshold. Definitely there. Switch the signal generator back on. No, the squelch performance isn't good enough. Right, what we're going to do is I'm going to look underneath this radio and see whether it looks like any of the parts have been changed. I think I'm going to have to email the customer and say, does he want this thing removing? Because what we don't want is to go around scratchy corner and it going which is at the kind of, what was it, 2-ish, something like that. Not good. 2 microvolts for the squelch to open. The worst ever squelch was the Team, is it the 8000 Pro or something, some swish looking mobile with atrocious squelch. So it's there. I can't see any of the parts have been altered. So it looks like we could just put it back as ceramic filter. So I'll have a word with the customer. I want to go and do a funeral, and we'll come back in a few hours. Right, folks. Well, I've had a word with the customer, and this is now 5 o'clock in the evening, having left at 10:30 this morning. 2.5 hours on that funeral. Customer agreed with me to take that crystal filter out and put a ceramic one back. Now, to try and keep his costs down, what we'll do is recover a second-hand one off a scrap chassis. And sometimes we buy scrap boards in this kind of condition, probably pay £2 for something like that. I wonder what, I don't recognise it, it's so smashed up. It's probably one of those Midland 095s. So that's still got its ceramic filter for 455. It's still got its ceramic filter for 10.695. So we'll have that out of it. And I'd rather do that than try and order a new one and wait 6 weeks for it to arrive. We have got some new ones in stock, but they're not free. So I will unsolder that. Right, that's that out. At least we know it's the correct type. Because I'm no expert on altering. I'm convinced that you've got to change some of the components to have the impedance matching, and this doesn't appear to have happened on this radio because I can't see any soldering in the vicinity. Anyway, if this doesn't function right, we will have a look at components around in comparison to the circuit diagram, but I think this is all they've done. Well, certainly they've got rid of bleed over, wouldn't they, because they made the set less sensitive. And I've let this go had it not been affecting the squelch so badly. So I'll return that with the set. I'm just going to have to find, I think these have to go in the right way round, so I'm just going to have to find either another scrap Cybernet. This is a York 861 which has seen better days, but we're not scrapping it. I'm kind of keeping this one together. I've bought it in like this, but it may be one of those sets we can resurrect at some point in the future. Or is the board smashed in half? Yeah, it's had a lot of work in the transmitter in the past. So we can see the filter in there is that way around, so the writing's towards us. So I need to give that a quick clean with isopropyl because it was not the best solder in the first place, and it certainly isn't now it's been removed and soldered again. Don't want the flux residue there. Good. I'm going to put the bottom back on because you have a capacitive effect. I think we'll put one screw in that so that it doesn't go walkies. What's happened to that top, do you think? Do you think it was laid the fag across there? So this can affect everything in the receive. So what we're just going to do is I'm going to just run through the receive again. Just see where we are immediately. 12 dB. So without touching the tuning, we're at 0.5 of a microvolt for 12 dB. It was 0.7. So straight away, we've improved the sensitivity to where I'd expect it to be. And I would expect it to be 0.5 or better. So what we're going to do, we're just going to put the oscilloscope on. We're going to check that detector. So I have no idea why all these cameras seem to be wanting to be reset every day. But you see, there's a very, very tiny difference on there. Right, let's go to the cyanide meter and see whether we can, whether there is any change whatsoever. So 4 dB on the meter. The front ends remain the same. Put a bigger signal on that. Some slight changes. Let's see what we've got. So for 12 dB, yeah, we're on that meter. Just get that really carefully on the dot. It's 0.48 of a microvolt. So now 10. And if we can we've got that from 1.65 to 1.2. Right, squelch time. So hopefully we haven't changed the squelch. Let's turn that to full. Put this back on the attenuator controls. So 3 microvolts, 10, 30. No, it's too sensitive now. So we've now got 100 microvolts. And now we'll test it at the sensitive end. So we've put the signal generator to standby. It's parked at 0.3 of a microvolt. Carefully set the squelch to threshold. Switch the signal generator back on. Now, as the signal generator came back in, we just heard it for a split second. It wasn't doing that before. So we'll just see where we are now. It's 0.9. There we go. You know, that's what we want. Not plumbing 1.8. That's what they did done. It's to ruin the squelch. Right, we'll just recheck the S meter. Just reset that. I don't know whether I set it before, whether we got that far. And we now have a more sensitive radio. So we've tested the mic, and we've now got 100 microvolts there, and we've done that. Deviation, just recheck, so I didn't write it down. Wallow, yes, been done. 2.2 to 2.5 kilohertz, and it's 27.79. It's now 125 exactly. There we are. So we've ended up with a really satisfactory result on that. I'm pleased. Does the transmit light work? Yes, it does. There's a bulb on these. Just to finally check where we are with transmit. This is stabilised. Just want to. It's 500 milliwatts. There we go. Oh! Hang on a minute. What's this inside? Well, there we are. There's a ceramic filter. So we'll put this into stock. That, whoever put that crystal filter in and kept that ceramic filter like that, well, that was the right thing to do. Okay. Well, that's not going to cost him anything now, is it? think the person who did that thought, oh, they're not going to like this, they're going to want to reverse this. They are, oh yes, they're going to want to reverse this. So we're about to, I think there's a little bit of snow still. We don't get much snow here at all, and I really mean that. You know, it can snow 7 miles down the road, but not here. But we have got a little tiny bit. If you saw yesterday's on the air test, it was not exactly doing much apart from mesmerising the driver. But there's been a little tiny bit. We've probably had a whole inch, but it's not really settling on the roads. It's better not do. I've got places to go and things to do, and I won't be going in the chapel today. If you think I'm walking down the garden path to do anything with the organ, I'm not. Good. Right, well, I'm going to turn this test set off. Unplug the test speaker. And plug in the Antron 99 or whatever kind of 99 it is. I think it's a Solarcon 99. I don't think it's a Cadbury's 99. I'll move it off that channel before we start going down that avenue. What on earth's that? Something from abroad? 19 Roger. Oh, we're on low power. 1 Nano Roger. So we set the power meter, but now we put it on an aerial. When I key up, it says just over 3. But we know the radio is doing more than 4. So it's just over 4. So this is what I say about these power meters. It's totally down to the impedance and all that with the aerial. So there we are. We'll not leave that on 19 because I don't want to listen to them. And I'll leave it on a proper channel like 31, and we'll have it on the air test later on. So I said I didn't expect to have to do anything with, apart from a retune, and then we had to do that demodification. Thanks for watching.